Hey guys, Will from Boosted Media here. So MOZA have reached out to us and asked us to put together a settings guide for their brand new R21 Ultra wheelbase for F125. So that's what we're going to be covering today. Now, there's a couple of fundamentals that I want you to be aware of before we get started today. Firstly, force feedback is a very subjective thing. So what feels good to me might not necessarily feel amazing to you guys. That said, there are a few fundamentals that are just key to making sure that what is happening inside the sim is communicated through to your hands accurately so that you get a good feel for what the car is doing underneath you. So in today's video, I'm going to be running you through all the settings, both in Pit House and in F125 itself, to make sure that you're able to understand how everything works and fine tune things to your own personal preference. Now, I'm going to be providing you guys with a baseline profile as well, which is my recommended settings that should be pretty good for everybody. And then you can fine tune and tweak from there with the knowledge that you'll gain from today's video. So without further ado, let's jump into MOZA Pit House. And the first thing that I'm going to want you to do is go down to the little sprocket here, the settings menu. We're going to click on check for updates and make sure you're running the latest version of the software. So I'm running version 1.3.4.32. Now it is really important here, software versions and particularly firmware versions can have a very large impact on the actual driving experience. So I can't guarantee if you're running a different software and firmware version from me, what your experience is going to be like. But again, you should be able to use these settings at least as a baseline to tweak from. So once you've got your software updated, you're going to move up to this little cloud icon here with a little red dot next to it. That is your firmware upgrade page. So I'm running version 1.2.7.13 of the R21 firmware for reference here. Again, if you're running a different firmware version to this, your experience may vary. Just check that you don't have any new firmware updates available for your base or any of your other connected peripherals. I do have a firmware update available for the display on my FSR2 wheel here, as you can see, and it's also saying there's a firmware update available for my M booster pedal, but the number here is actually higher than I'm running than the latest available version. That's simply because I'm running some experimental software for testing these pedals at the moment. So click on the firmware update manager and you can see there will be a drop-down menu that allows you to choose the firmware version you want for each one of the connected peripherals, or you can just click on update all and it will go through the process. Just be aware the dash on these wheels does seem to take quite a long time to update. So allow sort of 20 minutes or so for this to go through if you are updating a dashboard. Otherwise, if you're just doing a base or something like that, it only takes a minute or so. Once you finish the firmware update process, it will prompt you to run through a wheelbase calibration process. Now, this is absolutely vitally important that you allow it to do so. It will ask you to disconnect the wheel before proceeding. What that's actually doing behind the scenes, among other things, is calibrating the motor to the actual magnetic fields inside the motor. That's very basic terms for explaining it. But when you rotate a motor shaft, it actually passes past a whole bunch of magnets around the outside or the inside, depending on the motor type. And what happens is as you transition between magnets, you get a slight what's called torque ripple or cogging effect, where it sort of wants to feel like it's pulling the wheel into the next position. Now, the firmware side of things has all sorts of things it does to sort of counteract and mitigate that issue. But if you don't run the calibration, you will find that the wheel feels quite notchy and yeah, it just doesn't feel quite right. So really important that you do that. If for some reason it doesn't prompt you, there is a setting underneath the base settings to actually force it to do that. You can click across to the base here, scroll down to the bottom and click on wheelbase reset and calibrate, just in case you need to do that. So once your software is updated, your firmware is updated, and you've run through the calibration cycle, what you're going to do is click on the home tab here, and here you're presented with a couple of basic settings pertaining to both the wheel and the wheelbase, as well as your pedals if you have MOZA pedals connected. So first of all, we have our center button. Now, pretty self-explanatory here, but you're going to want to set your wheel to center. After the motor calibration, it does seem to throw itself out by about 180 degrees. So set your wheel to center and then click on the center button, and that is going to ensure that it is calibrated to dead center. You can see I was 1 degree out there on my calibration previously. Below that, we have maximum steering angles. So for F125, you're going to want to set this to somewhere around about 360 degrees, maybe somewhere up to 400. What is absolutely critical here is that you have it set to the same in the software here as you have it set inside F125 or any of the other F1 games. If you have a mismatch here, you're going to find that the amount that you're turning the wheel inside the game is completely different from what you're physically turning it on your wheelbase. So you don't want to have that scenario. Some people like to run slightly oversensitive, but that's up to you to decide. There's a few esports guys that I know do that, but Under normal circumstances, I would recommend setting both to 360 degrees. Up on the top here, we have our game force feedback intensity. We're going to be talking about that in more detail in just a second. And then we have a little switch here for work mode. This is basically just enabling or disabling force feedback as a universal setting. So if you switch that off, you're not going to have any force feedback. We're going to leave it on for obvious reasons. So we're going to click down to the wheelbase next, or just click on the More tab here. And that is going to take us into our basic settings for the wheelbase. So from here, you can import the profile that we've provided to MOZA, which hopefully they will supply it to you guys via their download page. And you can see it's already preloaded here because I am running F125 in the background. Now, you can use this profile for other versions of the F1 games as well. I tested it from F1 2018 all the way through, and it was pretty good across the board. Obviously, there's going to be some little tweaks that you might want to make to your personal preference, but yeah, should be pretty sweet for all of them. I've only got it set to auto load for F125 though, just so there's no confusion there. But you do have a drop-down menu where you can choose any one of the profiles that you've got loaded manually via the import button, or any of the profiles that are pre-baked into the software from MOZA themselves. Down below that, we've got our maximum steering angle adjustment. Works exactly the same as what we saw on the homepage before. With one little variation here, you can actually decouple the physical mechanical rotation from the sensitivity. So what that means is that if you want the game to actually be able to read beyond that 360 degrees of mechanical rotation that we have set here, you can do so. So direct drive wheelbases mechanically can rotate infinitely. And you can see this one here has a total measurement range of between 90 degrees and 2,700 degrees. So if you're running truck sims, you can have it rotate a lot more. But what it does is when it reaches that end stop, it gives you a mechanical stop that is software controlled and adjustable down below, as we'll see in just a second, to create that bump stop. So you can see at the moment, if we go back to the home page, when I reach 360 degrees of rotation, it is not moving any further, even if I push the wheel further. If I decouple them and I wind this up to say 500 degrees, but then wind the actual physical rotation back down to 360, now I can push past that point and it does still actually give me a reading inside the game. So again, it will depend on how you've got your game set up. Those of you who like to be able to push slightly in to your bump stop and still have it actually impact the steering in the car, you understand how this works now. So you can tweak to your heart's content, but I prefer to just leave it on synchronous and leave it set to 360 degrees. Now, we were just talking about the mechanical feeling of that bump stop. Being a direct drive wheelbase with infinite mechanical rotation, you have control over what that bump stop feels like. So from 1, the softest setting, all the way up to 10, which is much more like hitting a brick wall. I find that that feels quite bouncy. It's more like hitting a rubber wall, to be honest. So I find that, if I do hit that bump stop when I'm driving and it's too stiff, it kind of wants to rebound back and it can send a big twitch through the car. So not that you'd ever really be bouncing off the bump stop anywhere anyway in F1, but I prefer to leave this down around about the 3 level. I find that that feels pretty good for me. Soft limit strength we can leave on middle, and we don't need to use the soft limit game force strength, so that can be left to off. If you do run into any glitches, you can soft restart your wheelbase from here, and you can also run, as we saw before, that wheel reset and calibrate procedure if for some reason you need to. So up on the right hand side now, we get into our game force feedback settings. This is where things start to get a little bit more complicated. So this is a 21 Newton meter wheelbase, which is more, in my opinion, strength than anybody realistically is ever going to need, unless you're the Hulk, let's be honest. So what this setting allows you to do is limit the maximum amount of dynamic range available. Now, by dynamic range, what I mean is basically the variation of strength available between 0 and the maximum. So in this case, we've wound it down to 16.8, which is a little bit more than what I think most people would need. I think the sweet spot for most people is going to be somewhere between about 10 Newton meters and 14 Newton meters of strength. That is the point for most people, again, unless you're the Hulk, where the car will begin to drive you rather than you driving the car. So you're starting to require explosive muscle inputs, which don't have as much finesse as fine motor controlled inputs. So yeah, somewhere between 10 and 14 Newton meters is typical. I set the wheelbase to 16.8 just to give us a little bit more headroom for clipping, which we'll get into in just a moment. But if you are allowing small children to run on your rig, which is a possibility with titles like F125, definitely don't want to be running anywhere near this strength. If you've got somebody under, say, about 12 years old, I would recommend actually running it all the way down at 5 Newton meters, for them, just to ensure that it's going to be relatively safe. Now, if the wheel does whip around on them, it can still injure them. This definitely isn't a toy. It is a serious piece of machinery. But I've actually broken my thumb at, I think it was 14 Newton meters of torque in the past when I've hit a wall and the wheels whipped around on me unexpectedly. My thumb was through the center. So yeah, not something to be taken lightly by any means. 16.8 is where I would recommend it be for most adults to allow a little bit of clipping headroom. Now, up above that, we've got our game force feedback intensity. I like to set this to somewhere around 70 to 80%, just to give us, again, a little bit of headroom before we run into clipping. And then we do have a professional game force feedback adjustment here that allows us to boost past that 100% intensity if we want to. So not really too many scenarios where I could see anybody wanting to do that, but I would recommend leaving both of these set to the same value. You can see if you increase up here, it will also increase down the bottom. It's only if you push past 100% that you see a decoupling between the two. So we were mentioning clipping before. What exactly is that? So clipping is where the signal coming out of the game exceeds the wheelbase's ability to actually produce that signal. So if we relate it to a stereo system, for example, imagine you plug an aux cable into the headphone jack on your phone and crank the volume all the way up on your phone. I'm sure most of you have experienced at some point where you start to get distortion through the speakers, even though the volume on the actual stereo itself is turned down quite low because the output signal of the source device is too high and therefore square waving or clipping at the top. So it's exactly the same, well, pretty much for all intents and purposes, the same with direct drive wheelbases as well. If the signal level coming out of the game is too high, there's not enough headroom left to actually account for that, and you end up just sending a numb signal through the wheel. So what that means in terms of the driving experience is if you run into clipping, all of a sudden the wheel's just going to feel vague and numb, and you're not going to have any definition or any fidelity in the wheel. So under scenarios where you're like hitting a wall or something like that, not necessarily a huge problem because you're already out of control anyway. But if you're mid-corner and you're already right on the edge of clipping and you push just that little bit harder, suddenly run into clipping, suddenly you're going to lose all the sensation in the steering. It's actually going to feel like the car is understeering when it isn't. So you can imagine how it can be really misleading and detrimental to the driving experience. So we never want to run into a scenario where we're clipping. And so what we want to do is allow enough dynamic range that we're within our safety limits, but we still have a little bit of headroom there just to allow for those kinds of scenarios. Then we wind our game force feedback intensity back just a little bit in the software to make sure that we're not overwhelming the driver software. And then what I like to do is actually fine tune the strength that I'm feeling through the wheel via the force feedback intensity settings in the game itself, which I'll show you in just a minute. And F125 is actually pretty cool. It gives you individual adjustments for a lot of different elements of the force feedback rather than just one master gain or one master force feedback control. So that is what I would recommend for those settings. Underneath that, you've got force feedback reversal. Don't need that for F125. Then we've got hands-off protection. When you let go of the wheel under some scenarios, the wheel can start to buck from side to side or oscillate very, very quickly, and that can actually be quite dangerous. You can imagine if it whips around when you're not expecting it, it can, catch on your hands and, cause all sorts of problems, or snap a cable to your wheel if you're running a cable back to your PC, for example. So we want to have things in place to mitigate this problem. That is what hands-off protection does. Basically, like an auto steering car that you might find on a road these days, when you take your hands off the wheel and the car starts whinging at you to put your hands back on the wheel again, this works exactly the same way. It's detecting the small amount of damping force or torque that you're applying to the wheel, just keeping it straight. And in the absence of any sort of feedback like that, it just disengages the force feedback. So there is an inertia setting here for this as well. You're going to set that based on the wheel that you have connected to your rig. So there is a slider, so you can adjust it for a variety of different wheels, or you can just use a preset like what we have here for the FSR wheel that I have connected right now. So below that, we have our maximum wheel speed. This is related to slew rate, or the motor's ability to quickly change direction or adjust torque levels. So the higher you go with this, the more reactive and lively the wheel's gonna feel overall. But it does get to a point with a wheelbase like this where it can just feel overly lively and hyperactive, basically. So I would recommend start off with a setting of 100 here. And if you do find that the wheel just feels too lively and too sharp overall, you can start to wind this down. And I would always recommend start winding this down before you start introducing damping, because damping will also damp down things like granular track detail, curb effects, grass effects, and so forth. Whereas reducing the reactiveness here doesn't have that same impact on some of those other effects. So adjust this first. If you're still finding that the wheel just feels too sharp overall, even when you crank this down, then you can start to introduce a little bit more damping. So that is everything under your basic settings. Then we're going to jump across to the advanced settings, and this is where we start to get into the filtering side of things. So for F125, I would recommend a force feedback interpolation level of 2. What force feedback interpolation is doing is creating artificial packets of force feedback data in between the actual packets of data that are being sent by the sim. So the physics refresh rate will vary depending on the sim title that you're running. iRacing, for example, runs at 60 Hertz, inherently at least. So what this does is it's able to smooth out effectively the force feedback in between those packets so you don't get the sort of stepping effect. So if you are finding that the force feedback just feels a little bit grainy to you, you can increase this a little bit further, but the further you increase it, the more it's kind of smoothing things out overall and reducing overall details. So you will start to feel the impact on those more granular details. It's kind of like running an AI filter on a picture, or, you know, if you ever watch shorts on YouTube, you'll notice a lot of the shorts kind of look all smooth and just weird. This is basically doing the same thing to your force feedback, so that's probably the best way to understand it. So below that, we've got our force feedback center dead zone compensation. So this is like a non-linear response adjustment that ties in with our base force feedback curve here, which we'll get into in just a moment. So what this allows you to do is, if you find that the steering feels a little bit vague around center, you can increase this value and it's going to give you a more linear feeling throughout the entire rotation of the steering. So most sims do a pretty good job of, you know, giving you a pretty good feeling throughout the rotation, so you don't tend to need this too much. F1 does tend to feel a little bit vague just around the center. So the initial kind of pull off, you're driving down a straight, and then when you initially start to turn in, it can just feel a little bit vague. So I've actually preferred to run a little bit more than some other people might like here. I ran this at level 4, but if you are finding that it feels too stiff around the center, it feels unnatural to you, then what I would recommend is crank this down a little bit, and that should correct that for you. So that is the force feedback center dead zone compensation. Below that, we've got our natural damping. Now there's quite a bit of damping already inherent in the force feedback coming out of F125, so I actually preferred to run this at 0. But if you do want to numb things down, if it's feeling too reactive for you overall, you can increase that natural damping. But again, I would generally recommend mucking around with the wheel maximum speed first. What you may find is if you crank the maximum wheel speed down too far, you actually start to get a desync between when the car rotates. So say, for example, you get a big snap oversteer and the car whips to the side quickly, but the steering can't quite keep up with that rotation because it's not able to react quickly enough. Whereas the higher you put this setting, the more quickly it's going to be able to react. So if you're starting to feel disconnected from the car's quick steering inputs, then you want to increase this setting. And if it's feeling too reactive for you when you do that, that's when you would start to increase a little bit of natural damping there. Some other sims I run sort of around 10% or so, but for F1, didn't find the need to run that at all. Natural friction, this gives you the sensation of mechanical weight in the steering. So obviously in a real car, the steering is connected to a steering rack, which is then connected to your wheels and tires, which have friction against the road surface. So it's not just a floppy wheel that's just turning freely in the air. This is what allows you to simulate that at a driver level. Now, F125, like most other sims, does a pretty good job. In fact, F125 actually does a better job than a lot of other sims at sort of creating this effect through its own force feedback inherent in the game physics. So for F125, I actually run natural friction at 0, although I do run a little bit of natural inertia. You can see I've got that set to 150, which is the first step over 100, just to give a little bit more sensation of weight in the steering. It's not stiff to sort of overcome as you're reacting and making short, sharp adjustments to your steering like you do in a Formula style car, but it does just slightly give a sensation of the wheel wanting to continue in the direction that it's turning, which gives a little bit more sense of connectedness, at least to me. But again, you can run this at 0 or run it even higher if you want to. What you will find is if you go too high on this, it becomes very difficult to quickly change direction because the wheel feels really heavy when you try to flick it back the other way. And again, we start to get into that territory of requiring explosive muscle inputs, which again loses finesse in your steering inputs. So definitely wouldn't recommend going that high, but you are of course free to play around with that to your heart's content. Then over on the right-hand side, we have our wheel spring strength. This is more a setting for games that don't have a wheel centering force built into their force feedback, or games that don't have any force feedback at all. So the wheel will naturally want to try and return to center. So for games like F125 and pretty much every other sim racing title these days, to be honest with you, you just leave this set to 0. Gear shift vibration intensity. This is completely subjective. If you don't have any other haptics on your rig, you can add a little bit of this, and what it will do is give you a slight clunk through the steering when you change gears. If you run it too high, and I probably actually do have it a little bit high here, I'll crank it down and resave this profile for you guys. If you you have it too high, it will twitch the steering a little bit. So if you're mid-corner and you change gear, you may find that it slightly upsets the balance of the car. So I'd recommend starting off at 0 and then slowly introducing it until you find the sweet spot for you. Direct input effect tuning. This is basically like a modifier for the signals that are actually coming out of the game. So for all sim racing titles these days, I would recommend just leaving these all set the same unless you've got a specific reason to make an adjustment there. Remembering again, we do actually have modifiers inside the game itself, so you shouldn't need to change anything here. Speed dependent damping. Again, this is going to be a pretty subjective thing. If you find that the wheel feels natural at lower speeds but starts to feel unnatural at higher speeds, you can introduce a little bit of speed dependent damping here, and you can adjust the intensity as well as the trigger speed for where you want that to occur. But for F1 25, again, I would recommend leaving this set to 0. Below that, we've got a temperature control strategy. So look, under most circumstances, the wheelbase isn't going to get anywhere near the maximum of 50 degrees here anyway. But if you are running in a really hot environment where it does start to approach that, what will happen is the overall strength will start to taper off to protect the electronics and the internals of the motor. And there are 2 profiles here. So conservative maxes out at 50 degrees before it tapers, and then radical, which allows it to get a little bit hotter at 60 degrees before it tapers off. So I think most people are going to be absolutely fine with conservative, but if you are in a hot environment, you're finding that it's overheating all the time and tapering off, you can choose to run that radical mode. And I'm sure that that would be absolutely fine. I can't imagine that that would include that mode if it wasn't safe to run the base over 60 degrees. But again, I've never even felt this thing become more than just a little bit warm to touch in the 23 odd degrees Celsius environment that we have here in the studio. So that is absolutely fine. We then get across into our force feedback equalizer. So this is like granular control for some of the more high frequency effects that you feel through the wheel. So you can see it starts off at a range of 0 to 10 hertz. That's simulating things like suspension and body movement. And what you've got here is a scale that goes all the way through from 0 hertz all the way up to 100 hertz of high frequency vibrations. You can see each frequency range here is labeled to give you an understanding of the kinds of effects that fall within that frequency range. So for example, 60 kilometer an hour sand effects, 240 kilometer an hour curb effects, 80 kilometer an hour curb effects, and so forth. And then we're able to individually adjust the amplitude here, so we can boost or increase the gain or attenuate or decrease the gain depending on what you like. So if you're finding that there's one particular frequency in the force feedback that's really bothering you, just like with an audio system, you know, if you're finding that the mids are just a little bit too overpowering, or maybe something sounding a little bit tinny in your headphones, you can use the equalizer to bring it down. You can think of this pretty much just like an equalizer for your force feedback. So if there's a particular frequency that is problematic or bothering you, you can just wind it down or boost it up depending on your preference. So I would recommend for F1 a setting of around about the 7 mark here, or you can customize it like I've done here to tweak it a little bit more. So just so you guys know, I'm running 20, 40%, 60%, 80%, and 100% for the last 2. But it is a very subjective thing. We're talking about very, very, very small details here. So spend the time here to fine tune this to your personal preference. Base force feedback curve. This is what we were talking about before, tied into the force feedback center dead zone compensation. So if you're finding that the wheelbase just doesn't feel linear in its rotation, some sims or games do a better job of this than others. Some actually feel quite notchy around center. You can use a non-linear response curve here to fine tune that out. But for F1, only a very, very small adjustment here I found was necessary, and some people may find that a perfectly linear curve is absolutely fine. If you want to run something really aggressive, you can run some of these presets here, or you can grab each node and move them around. So essentially what you've got here, just so you understand exactly what it's doing, is you've got the output from the game along the bottom axis here, and then the actual output that it commands of the base. So at 20%, you can tell it to actually output 40%. At 40%, you could tell it to actually output 60, or you get the idea here. Those are the adjustments that are available there. I'm going to set it back to linear and then give myself, you can see when I set it to linear, it actually zeroed this out again. So I'm going to set it back to level 2 or so, and that should be absolutely fine. So then we've got a tab for miscellaneous. This allows us to put the base into standby mode or disengage force feedback. You've got a base Bluetooth switch here as well. So there is actually a smartphone or tablet app that you can use to make all of these adjustments that you see in the software here, to save you having to alt tab out of the game to adjust your force feedback settings. So that is quite cool. If you want to use that, you're going to need to have the base Bluetooth turned on. Bass status indicator, so if you're running a bass that has a light on the front, you can switch that light on or off. This particular bass doesn't actually have one of those, so it's kind of a bit of a redundant feature. And then if you want to, you can also have the bass play some startup music when you switch it on, because the high frequency effects that these motors these days are capable of, you can actually have it play music. So yeah, you might find that you like it. For me, I found that I was over it after the first time, so I just left it switched off. But you can also adjust the volume there as well. So that is everything under miscellaneous. Button mapping, this is an important one. So for F1, it seems to be absolutely fine to just run it in single mode. So that gives you 128 individual possible outputs, depending on the wheel that you have connected, of course. If you're running a sim like Automobilista 2, for example, that doesn't understand more than 32 inputs per device, what you can do is you can split it up. So you've got your main device, and then you've got 3 additional virtual devices to give you a total of 4 devices, each with 32 individual inputs. So that allows you to make full use of all 128 inputs available. For F1, it seems to be absolutely fine running in standard mode. And then lastly, under base LED, we've got some tweaks and adjustments we can make to the LED strips on the base itself. So we've got a telemetry mode, which we'll get into in just a second. We've got a non-telemetry mode, which basically just allows you to have effects or a static light on the LED strips, or if you don't like that kind of thing, you can just switch it off entirely. You've got an adjustment here for brightness too. Obviously that's just purely subjective. You've got a sleep timer here, so you can have it switch from telemetry or from static idle effects into sleep mode and have a different effect for sleeping. You've got a drop down menu here, so you can choose whether you want off or breathing mode. I'm guessing they'll probably add some more effects here over time. You can also adjust the color for each individual LED. So you've got 9 individual segments on either side. You can click on those LEDs and adjust using the color wheel, put in a hex value, or just use a preset from the selection menu here, or even click and drag your RGB sliders to get exactly the color that you want. And again, that is configurable for each of the buttons. And then you also have a speed adjustment for the animation too. Just the same under idle effects, you've got a constant, a breathing, color cycle, rainbow, or sand flow effect. And again, you can click on each individual LED to make adjustments to the color, just like what we saw before. Down below that, we've got our telemetry effects. So this will depend on the sim racing title that you're running, but this is like a hierarchical chart. So if I enable another effect like say pit limiter, for example, and add that in, you can see now it adds it to the queue. Now, if I were to add say something like traction control as well, now what's going to happen is the first thing that it's going to always display is RPM. If the pit limiter is active, it will then display the pit limiter over the top of that. If traction control was then to kick in for some crazy reason while you're in pit limiter mode, it would display that traction control. If we were to shuffle these around, what would then happen is pit limiter would show, traction control would show over the top of pit limiter, but RPM would always show over the top of both of them. So it kind of wouldn't work the way we intend. So the hierarchy that you set here is important. And there are a whole bunch of effects, as you saw before, depending on the sim that you're running, for all kinds of different things, including track status as well. So red flag, yellow flag, blue flag, green, white, and black flags, and so forth. So you can tweak that to your heart's content, but again, it will depend on the sim title that you're running. And that is pretty much everything you need to know, I think, in terms of the MOZA Pit House software. So let's quickly jump into F125 now, and I'll show you the adjustments necessary in there. Okay, so inside the F1 game, the first thing that's going to happen the first time you load up with a new wheelbase or a new wheel or any other new peripherals is it's going to prompt you to map your controls. So once you've gone through and done that to your subjective preference, you're going to want to go into the force feedback settings menu. So we go into our settings menu, we go to controls, vibration, and force feedback, and we go to the preset that pertains to our particular configuration that we saved during the mapping process. So for me, I've got a profile set up here called R21 Ultra. Just don't go into one that isn't highlighted by accident, or your keyboard profile, because any adjustments that you make won't actually take effect on the devices that you're using. So we're going to go into our R21 profile here, or whatever you've named it. We're going to go to edit, and you can see here the controls that I've already mapped for the sake of this video. I'm not going to go into control mapping here because it will depend entirely on the wheel that you're running, but all the basic controls are here. What we're interested in is vibration and force feedback. So we're going to click on that. You can see we've got our vibration and force feedback turned on, pretty self-explanatory. Below that, we've got individual adjustments for a few different parameters. So vibration and force feedback, this is like an overall strength adjustment. I like to have this set to 75, on-track effects 80, rumble strips 80, off-track effects 85, because I like to get a bit of a punishment when I go off track. Pit stop effects purely subjective there, not going to impact the driving experience at all. Wheel damper, as it says over on the right hand side there, this is basically simulating the strength of the tire forces through the wheel. So I usually leave this set to 100 in F1, and all the other effects kind of, work over the top of that. And then as we discussed before, we want to set our maximum wheel rotation here to be the same as what it is in the sim, or if you want to have a small offset just to make it slightly more sensitive for tracks like Monaco, for example, or maybe Azerbaijan, then you can do that too. But yeah, generally speaking, you just want to set it 1-to-1. So look, these are purely subjective here. What I wouldn't recommend doing is having it over about 90% for your overall strength, because that's where you may start to run into a clipping signal actually coming out of the sim. And then whatever you do in the driver software isn't going to really matter, because the signal that's actually going into the driver is clipping already. So if you find that with those other settings that we looked at before, it is still a little bit too stiff for you, then you can crank down your effects here to tune it to your personal preference. Again, remembering that if you are jumping on and allowing a small child to run on your rig, don't just adjust the strength of the force feedback here. Make sure you do cap that dynamic range, as we saw before, by limiting that output power to around 5 Newton meters, just to make sure that there isn't going to be a scenario where something could go crazy and injure them. And yeah, it is as simple as that, guys. So happy racing. Hope the video has helped out. Let us know in the comments down below how you go. Remember, again, I can't guarantee the experience running different software versions and firmware versions, but really hope this video has helped you out. And yeah, happy racing. See you again soon. Bye.